All right, now that you understand how integers work with the 4 different types that Kotlin has to offer for integers, let's look over to floating types. So just scroll down a little bit on this page if you want to read through it. And again, it just uses a bunch of numbers and stuff and explains it this way, but I'm just going to do it my way. So basically you can see there is a float, which allows us to store 32 bits of data, and there is a double, which allows us 64 bits of data. So depending on the amount of digits that you have inside of your floating point value, you could use either a float data type or the double data type. All right. By default, however, Kotlin just uses double. So as you see, we just have too much memory available. That's why it's not a problem to just go always with the bigger type. Or not the biggest type, but the bigger type. In this case, it is the biggest because there are just 2. But basically, you can see if you want to store pi with 3.14, then this will automatically be stored as a double. So you see here val1 that we had before, this number. If we want to store it as a double, we get a type mismatch. So let's try these things in a bit. Before that, however, I want to just show you how to set up floats. You can see if you want to specifically say that a variable should be of type float without having to define it after the variable name assignment, you can use the f at the end of your number, and that will then automatically also make this a float, even if it cuts off. So you can see here, the actual value is not the same as the value here. So this, while being a double from its length, is stored as a float because we override it with this f. Okay, so let's just quickly test this inside of our little program. So we had my age in the last video, so let's get rid of that and test it with floats now. So I'm deleting all of this code. I'm going to create a new val. Let's call it pi, and this will be 3.14. All right. So now let me print it out, println, and print out pi. So let's rerun this code and see what it says. It says 3.14. Now let's also hover over pi just to see what data type it is, and we can see it's of data type double. So automatically it has been stored as a double. Now if we add the f to it, suddenly it is a float data type. All right, so that's how you can change the data type by just adding an f, or you can also obviously do it by using the old-fashioned way that we saw earlier, but then you also still have to add the f because otherwise this number is automatically considered a double. Okay, as you see, this is not necessary because it infers it, and it infers it because of the f as being a float. Now if you want to override pi with a very long number, and this doesn't work because it's a val, so we need to make it a var if we want to mute it or change it. So let's say we started off with 3.14, and pi is a constant, right? It's always the same, but the amount of data that we store about pi is not constant. So we could say we store 14159. I believe that's like if you want to go deeper. So that's the new pi. So I want to have more precision, so I'm going to use that. Now let me see, what is the pi 10 stellen? Okay, let me see that. So 10 numbers, so it goes 59145926. So 26535. Okay, so you see I get an underlined grayish color or brownish color or something like that, and that just says the floating point literal cannot be represented with the required precision. So the precision, so to speak, so the amount of digits that I assign to pi is now bigger than what a floating point or a float can store. All right, so you see it cuts it off here after the 6.5, like it says 265 should be represented as 7. So it just takes the closest next value that would fit. So now let's print pi again just to see what this does. And you will see that now the new pi will be this imprecise number. So it doesn't just cut it off at that point where it doesn't know what to do with it, but it's also at the same time rounds the number up, which could be a problem because if we use pi, we want to make sure that pi is what it is, right? So that's what we can achieve by getting rid of the f in both cases and making this a double, and suddenly we have the precision again. So doubles are more precise as floats. You can see we get all of the precision that we needed. So that's just for you to know there are different types of floating point values, and that's pretty much it for this video. So see you in the next one. And obviously also don't forget to do the exercises, please. All right. So see you in the next one.